All right, so we're going to talk about another method of solving systems of linear equations. So yesterday we did graphing, and we did the whole thing where you graph one equation on a coordinate plane, you graph the other one on the same coordinate plane, and you look for that point of intersection. And wherever they intersected, that point, that coordinate, x comma y, that was the solution. But graphing is not the most efficient way of solving these systems all the time. So we're going to explore a couple other options, and today we're doing substitution. So as it says right here, another way to solve a system of linear equations is to use substitution to obtain an equation with that only has one variable. That is the main point of substitution. You want to get rid of one of the variables so that you're left with just one. Then you're going to solve that resulting equation for that variable, whatever it is, and then take that value, substitute it back into one of the other ones to find the other variable. So in order to make this happen, you need to have, and you should be writing this down, one of the equations solved for one of its variables. And what that means is that that equation has whatever variable you chose alone on one side of the equal sign. That's the first step. You want to take one of the equations and make it so that it is in the form plain old y equals blah, 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 or plain old x equals blah, blah, blah. So in this example, that has already been done for you. So kind of like yesterday with our notes, it started off with me saying that you got to have it in slope-intercept form to graph it, but then it didn't show up till later. Same thing here. This will be an issue later on, but I want to put it first and foremost so it's always the first thing you think of. So when we solve by substitution, if y equals this, and this is also y, you're just going to substitute the y's for the y's. So because y equals 2x plus 3, and down here, this is also a y, I can replace it with 2x plus 3 equals 5x. By doing that substitution, I have now eliminated that y variable, and I only have one variable, x. And this is just a simple equation that I now just solve for x. So if we want to solve this for x, the first thing we're going to do is combine our variable terms on one side of the equal sign. So I'm going to subtract 2x from here and here. So I have 3 is equal to 3x. And then I want to get x alone, so I'll divide by 3. And you know that I'm picky about the order, so I will write it as x equals 1, not 1 equals x. So I have found my x coordinate. So far, my solution is 1 comma something. I have to find that something. So what I'm going to do is take this x equals 1, and now you have a choice. You always have a choice. I had a choice to plug this in here. I could have plugged 5x into the top one. It doesn't matter. So x equals 1. I'm going to plug 1 in for x in one of these equations. Your choice. I personally like the second one because it's smaller. I like to do the easy ones, whatever's going to make it go faster. So this is going to be y is equal to 5x. I'm going to plug 1 in for x. Y is equal to 5 times 1. So y is equal to 5. So that makes our point 1 comma 5. So that's how substitution works. And then Don't forget, we always want to do a check. So when we check, sorry, yeah, that's correct. So when we check 1, 5, I'm going to use both of these equations, y equals 2x plus 3 and y equals 5x, and substitute my values in. Y is 5, x is 1. So this is 5 is equal to 2 plus 3, 5 is equal to 5, I'm good. Y is 5, x is 1. This is 5 equals 5, I'm good. That tells me that 1, 5 is actually the solution to my system. All right. Let's take a look at example 2. For example 2, our first step, we want to make sure that at least one of the equations is solved for one of the variables. So one of the equations is either x equals or y equals something. So we have that here with this top equation. It's y equals this. Y equals 2x minus 4. So for substitution, I'm now going to take that 2x minus 4 and substitute it in for the y in the other equation. So my new equation becomes 7x minus 2 times 2x minus 4 equals 5. Notice how I put it in parentheses, because y is the whole thing, 2x minus 4. So I want to make sure that when I substitute it, I'm substituting the whole thing and applying. And now, once again, we have an equation with just x. So I solve. So thinking about now our steps to solving equations, maybe equations that have variables on both sides, multi-step equations. Here we have the distributive property. When you distribute, you want to make sure to take the whole number in front and distribute it. So this is negative 2 times 2x and negative 2 times negative 4. So this is 7x and negative 2 times 2x and negative 2 times negative 4. See, it's a negative, so it's a negative and a negative. It's got to be negative the whole time. That is a frequently missed concept. I see a lot of mistakes when you have to distribute with a negative. Let's simplify. This is going to be 7x minus 4x plus 8 equals 5. Continuing, 7x minus 4x is 3x. All right, we've got our equations simplified. Now we can start solving. Remember, peeling away the onion to get to the center. So I'm going to start by peeling away this 8. So I'm going to subtract 8 from both sides. And I get 3x equals negative 3. And then I'll divide by 3 on both sides. And x equals negative. Now we have our half of our solution. We know it's going to be negative 1 comma something. And we got to find that other coordinate. So you get a choice, top or bottom. So you get a choice, top or bottom, and you want to choose the one that kind of looks the easiest. It doesn't matter. If you chose the other equation and you did it correctly, you're still going to get it right. But you always want to try to make things a little bit more efficient. That top equation, where you only have one x to deal with and the y is already by itself, and that's what we're looking for in the first place, will require less steps than the bottom. It will take practice and time to get good at identifying which of the two equations is the best. So if you don't get it right away, that's okay. So let's plug it into the top. Y is going to be equal to 2 times x minus 4, and x is negative 1. So y is going to equal to negative 2 minus 4. That's going to be negative 6, making our solution negative 1, comma, negative 6. And like always, we are always going to check. So I got to check my point, negative 1, negative 6. I'm going to check it in. Oh, and we learned this yesterday. I always check it with my original equations, right? I know that I simplified one with one variable down here. I don't want to use that. You always do your checks with your original given equations. So that's y is equal to 2x minus 4, and 7x minus 2y equals 5. So here I'm going to plug in negative 6 for y and negative 1 for x. And I get that negative 6 does in fact equal negative 6. Yay. Here, I'm going to plug in negative 1 for x, negative 6 for y. And I get that 5 equals 5. So that tells me that my point is correct. Now, yesterday we talked about where should you look if your check doesn't work out. And we said the first place you should look is if you had to rearrange your equations into y plus mx plus b. The second place that you should look is on your graph itself to make sure that you plotted the y-intercept correctly and did the slope correctly. And then the last place you should look is the check. So for today, with substitution, generally it's the first equation where you made a mistake. So start there. Okay, for those of you at home, go ahead and pause the video right now and solve the two. Try it yourselves. All right, let's walk through these and you can check your list. So, for the first one, we have it solved for y. So I'm going to substitute 3x minus 4 in for y in our second equation. So this is going to become 5x minus 2 times 3x minus 4 equals 10. I once again have the distributed property happening here, and it once again is with a negative. So this will be negative 2 times 3x, negative 2 times negative 4. So 5x, and I have negative 2 times 3x. And then I have negative 2 times negative 4. Let's simplify. And combine our like terms. And I have a simple equation that I'm left with. So let's start solving it. Okay, this is another mistake that I see frequently. This is 5x and a negative 6x that I combined. 5 and negative 6 gives me negative 1. So that's a negative x. By subtracting the 8 from both sides, it is still a negative x. Negative x is not the same as positive x. I have to have it be plain old by itself positive x. So I got to get rid of this negative somehow. Some of you like to divide, some of you like to multiply. It doesn't really matter. Multiply or divide by negative 1 on both sides. And this becomes x equals 2. Let's plug it back in. Think to yourself, top or bottom equation. And we're going to go with the top. plugging it in here. So I'll have y is equal to 3 times 2 minus 4, since x equals 2. And y is also going to be 2, making our possible solution 2, 2. And I made a mistake there because I got too busy talking. So this is a -2 that x equals, after I made a whole big deal about that. This is -2, -6. This is -10. So our possible answer is -2, -10. There we go. Okay. Now let's do our check that will hopefully work out because I fixed my mistake already. I'm kind of running out of the room here, so I'm just kind of going to do the checks by skipping this first step where I wrote the equation and just kind of condensing it. So y is -10 is equal to 3 times x minus 4. -10 is equal to -6 minus 4. -10 is -10, that works. Our second one is going to be 5 times -2 minus 2 times -10 equals 10. -10 minus -20 equals 10, so that's -10 plus 20 equals 10, and 10 does in fact equal 10. So this solution does work. If you did not yet do the other one at home, go ahead and pause, do the other one, and then unpause to check to see if you did it correct. So this one's a little different. So as I was saying, this one's a little different because we've been used to seeing these solved for y, and this one is solved for x. The process is still the same. I'm going to substitute this part, but this time I'm going to substitute it in for x. So it's going to be 2 times 5y plus 3 plus 4y equals 1. So where we've been used to seeing our equation only having the x variable, now it's going to have the y one as well. -1. So let's distribute. Luckily this time it is positive, so that makes it a little easier. So 2 times 5y plus 2 times 3 plus 4y equals -1. That's going to be 10y plus 6 plus 4y equals -1. Let's combine our like terms. They'll combine to 14y plus 6 equals -1. And now we have a basic equation that we can start solving. Subtract 6 from each side, and I get -7. Divide by 14 is y is going to be -1/2. So then we're going to have to solve, and we want to know what our x value is. So once again, it's kind of always easier if you have one of the originals already solved for the one variable. It's kind of just easier to use that one. So if y equals -1/2, x is going to be 5 times -1/2 plus 3. That's going to be -2.5 plus 3. Oops, not y. So x is going to be +1/2. So our possible point is 1/2, comma, -1/2. And we want to check. So let's check with our first one. 1/2 is equal to 5 times -1/2 plus 3. 1/2 is equal to -2.5 plus 3. 1/2 is equal to 1/2. That one worked. For our bottom, 2 times 1/2 plus 4 times -1/2 equals -1. 2 times a half is 1. Plus -2 equals -1, and -1 equals -1. That works. So this is our solution. There may be situations that come up. We didn't have any in our notes today, and I'm not sure if it's going to be in our homework. So maybe this might not be something this year, but definitely next year, where if you don't have one of your equations already solved for one of the variables, but you still wanted to use substitution, you would do what we did yesterday, which is where we would just rearrange it. You'd have to rewrite that equation to get one of the variables along. Choose one of the equations and rewrite it for one of the variables. And whatever one you choose is your choice, whatever one looks easier, kind of. All right. Let's move on to some story problems. Same as yesterday, you are not going to do a check for your story problems. So we're going to have to figure out what our two equations are, and we're going to use the substitution method today. So in this first situation, you're planning a birthday party. You buy a total of 50 turkey burgers and veggie burgers, and you spend $90. You pay $2 per turkey burger and $1.50 per veggie burger. Write a system of linear equations to find the number of turkey burgers, which we'll use T, and veggie burgers, which we'll use V, that you buy. So, looking at this situation, I can see that I buy a total of 50 turkey burgers and veggie burgers. There are 50 total. So, T plus V equals 50, right? The number of turkey burgers plus the number of veggie burgers gives me 50, which is the total number of burgers. Then it's $2 per turkey burger, $1.50 per veggie burger, and I spent $90. So my second equation could have something to do with the price. $2 each times the number of turkey burgers plus $1.50 each times the number of veggie burgers equals the $90 total that I spent. So this was that situation that I was literally just talking about. We have two equations, but one of them is not already solved for one of the variables. So we're going to have to do that. So take a look at it for a second and think, which one would be easier to isolate one of the variables? Obviously, the top. It's always easier to isolate a variable that doesn't have a coefficient, or if the coefficient is 1, right? So we're going to go ahead and rearrange the top equation. Then you get another choice. Well, both of these variables have a coefficient of 1, so they're both viable options. Just choose one. It doesn't really matter. I'm going to solve for T because I feel like it. So T equals 50. Oops, that's just B. T equals 50 minus V. Well, here's a T in that equation. Here's a T in that equation. First step, substitute for one into the other. So this becomes 2 times 50 minus V plus 150V equals 90. And now we have an equation that just has one variable. First, we'll distribute. 2 times 50 minus 2 times V plus 150V equals 90. Simplifies to 100 minus 2V plus 150V equals 90. Let's combine our like terms. 100 minus 0.5 V equals 90. subtract 100, and this is another spot where you guys make a lot of errors. This is negative 0.5b. When I take away the 100, it's still negative. Negative 0.5b is equal to negative 10, and then we'll divide by negative 0.5 on each side to see that v is positive 20. Okay, I'm glad that this was one that we had to rearrange, because when you solve for one of the variables and you're going to plug it back in to solve for the other one, you have to choose one of the original equations. So write that little note to yourself. Substitute it into an original equation. Your original equations are here and here, not over here where you rearranged it. So let's do that. I'm going to say choose which one looks easier, which I think the top one looks easier. I'm going to do it over here though. So this is going to be t plus 20 equals 50. T is equal to 30. Now, yesterday we also talked about how when you have a story problem, writing it as a point for your answer doesn't really make sense because these values mean something. So V is 20 and T is 30. That tells me that I bought 30 turkey burgers and 20 veggie burgers. And that would be your answer. So now what I want you to do, if you're at home watching this, go ahead, pause the video, see if you can do this one, which actually, yeah, see if you can do this one on your own. Okay, our last one. On a school trip to a musical, adult tickets cost 3 times as much as children's tickets. The cost of 23 adult tickets and 55 children's tickets is $508.40. We want to know what is the cost of an adult ticket and the cost of a child ticket. So I'm going to make A is the cost of an adult ticket. And I'm going to make C is the cost of a child ticket. So one of the things it tells me is a whole sentence right here with the cost. 23 adults and 55 children cost $508.40. So 23 adult tickets times however much those cost, plus 55 child tickets, plus however much those cost, is going to equal $508.40. The next equation is a little more difficult to figure out. It says adult tickets cost 3 times as much as children's tickets. So adult tickets are 3 times as more expensive as a child. An adult ticket equals 3 times as expensive as a children's ticket. And remember, whenever you have a situation like this, or something like it's 4 more than, or 10 less than, or something like that, it always helps to just double check by plugging in some numbers. Let's say children's tickets cost $10. Well, then an adult costs 3 times 10, 30. If an adult's ticket is 30 and a child's ticket is 10, does that satisfy this situation? Yes, it does, because the adult is 3 times the child. All right, you got lucky here. We did have it solved for one of the variables. A is equal to 3c. So I'm just going to plug 3c in for A. So 23 times 3c plus 55c is equal to 508.4. This is going to be 69c plus 55c is equal to 508.4. 69 plus 55 is going to give me 124. C is equal to 508.4. Then divided by 124, and we'll see the cost of a child's ticket is 508.4 divided by 124, $4.10. It actually gave me the answer of 4.1, right? 4.1. That's great. You can leave that as 4.1 for now. We're going to talk about that a little bit later, though. All right, so I found my child's cost is 4.1. I'm going to take that child's cost and plug it in for C in the second equation because that equation looks a lot easier to deal with. So A is going to be 3 times 4.1. A is going to be 12.3. Sure, you want to keep it like that, but it really means $12.30. And here's why I'm making that a big deal. Because our final answer is not the point, 4.1 comma 12.3. We have to make it a situation reverting back to what we're talking about. So the cost of an adult ticket is $12.30. And the cost of a child's ticket is $4.10. I'm very picky about how you write your units. So money goes to pennies. You've been shopping before. You've been to stores, you know what it looks like. Money is always rounded to the 100th place to make sure that you are writing your money correctly. Okay, that's it.